Polycarbonates, known by the trademarked names Lexan, Makrolon, Makroclear, arcoPlus, a registered trademark, and others, are a particular group of thermoplastic polymers. They are easily worked, molded, and thermoformed. Because of these properties, polycarbonates find many applications. Polycarbonates do not have a unique resin identification code and are identified as other, 7. Items made from polycarbonate can contain the precursor monomer bisphenol A. Structure: polycarbonates receive their name because they are polymers containing carbonate groups A-O-. Most polycarbonates of commercial interest are derived from rigid monomers. A balance of useful features including temperature resistance, impact resistance and optical properties position polycarbonates between commodity plastics and engineering plastics. Production: the main polycarbonate material is produced by the reaction of bisphenol A and phosgene COCl, 2. The overall reaction can be written as follows. The first step of the synthesis involves treatment of bisphenol A with sodium hydroxide, which deprotonates the hydroxyl groups of the bisphenol A. HOC6H4, 2CMe2 plus 2 NaO and Na2, OC6H4, 2CMe2 plus 2 hours 2O, the diphenoxide 2CMe2, reacts with phosgene to give a chloroformate, which subsequently is attacked by another phenoxide. The net reaction from the diphenoxide is Na2, OC6H4, 2CMe2 plus COCl2 or 1/N, OC, OC6H4, 2CMe2, N plus 2 NaCl. In this way, approximately 1 billion kilograms of polycarbonate is produced annually. Many other diols have been tested in place of bisphenol A, for example 1,1-bis, 4-hydroxyphenol, cyclohexane and dihydroxybenzophenone. The cyclohexane is used as a comonomer to suppress crystallization tendency of the BPA-derived product. Tetrabromobisphenol A is used to enhance fire resistance. Tetramethylcyclobutanyl has been developed as a replacement for BPA. An alternative route to polycarbonates entails transesterification from BPA into phenol carbonate, HOC6H4, 2CMe2 plus 2CO or 1/N, OC, OC6H4, 2CMe2, N plus 2C6H5OH. The diphenyl carbonate was derived in part from carbon monoxide, this route being greener than the phosgene method. Properties and processing: polycarbonate is a durable material. Although it has high impact resistance, it has low scratch resistance, and so a hard coating is applied to polycarbonate eyewear lenses and polycarbonate exterior automotive components. The characteristics of polycarbonate are quite like those of polymethyl methacrylate, but polycarbonate is stronger and usable over a greater temperature range. Polycarbonate is highly transparent to visible light, with better light transmission than many kinds of glass. Polycarbonate has a glass transition temperature of about 147 AA°C, so it softens gradually above this point and flows above about 155 AA°C. Tools must be held at high temperatures, generally above 80 AA°C, to make strain and stress-free products. Low molecular mass grades are easier to mold than higher grades, but their strength is lower as a result. The toughest grades have the highest molecular mass, but are much more difficult to process. Unlike most thermoplastics, polycarbonate can undergo large plastic deformations without cracking or breaking. As a result, it can be processed and formed at room temperature using sheet metal techniques, such as bending on a brake. Even for sharp angle bends with a tight radius, heating may not be necessary. This makes it valuable in prototyping applications where transparent or electrically non-conductive parts are needed, which cannot be made from sheet metal. Note that PMMA cyclers, which is similar in appearance to polycarbonate, is brittle and cannot be bent at room temperature. Main transformation techniques for polycarbonate resins: extrusion into tubes, rods and other profiles including multi-well, extrusion with cylinders into sheets, and films, which can be used directly or manufactured into other shapes using thermoforming or secondary fabrication techniques, such as bending, drilling, routing, laser cutting etc., injection molding into ready articles. Applications: electronic components, Polycarbonate is mainly used for electronic applications that capitalize on its collective safety features. Being a good electrical insulator and having heat-resistant and flame-retardant properties, it is used in various products associated with electrical and telecommunications hardware. It can also serve as a dielectric in high-stability capacitors. However, commercial manufacture of polycarbonate capacitors mostly stopped after sole manufacturer Bayer AG stopped making capacitor-grade polycarbonate film at the end of year 2000. Construction materials. The second largest consumer of polycarbonates is the construction industry, for example for dome lights, flat or curved glazing, and sound walls. Data storage. A major application of polycarbonate is the production of compact discs, DVDs, and Blu-ray discs. These discs are produced by injection molding polycarbonate into a mold cavity that is on one side a metal stamper containing a negative image of the disc data, while the other mold side is a mirrored surface. Typical products of sheet film production include applications in advertisement, automotive, aircraft, and security components. In the automotive industry, injection molded polycarbonate can produce very smooth surfaces that make it well suited for sputter deposition or evaporation deposition of aluminium without the need for a base coat. Decorative bezels and optical reflectors are commonly made of polycarbonate. Due to its low weight and high impact resistance, polycarbonate is the dominant material for making automotive headlamp lenses. However, automotive headlamps require outer surface coatings because of its low scratch resistance and susceptibility to ultraviolet degradation. The use of polycarbonate in automotive applications is limited to low-stress applications. Stress from fasteners, plastic welding and molding render polycarbonate susceptible to stress corrosion cracking when it comes in contact with certain accelerants such as salt water and plastisol. It can be laminated to make bulletproof glass, although bullet-resistant is more accurate for the thinner windows, such as are used in bullet-resistant windows in automobiles. The thicker barriers of transparent plastic used in tellers windows and barriers in banks are also polycarbonate. So-called theft-proof large plastic packaging for smaller items, which cannot be opened by hand, is uniformly made from polycarbonate. The cockpit canopy of the F-22 Raptor jet fighter is made from a piece of high optical quality polycarbonate, and is the largest piece of its type formed in the world. South African security companies have launched the transparent burglar bar under a variety of retail names, made from polycarbonate. Niche applications. Polycarbonate, being a versatile material with attractive processing and physical properties, has attracted myriad smaller applications. The use of injection-molded drinking bottles, glasses and food containers is common, but the use of BPA in the manufacture of polycarbonate has stirred serious controversy, leading to development and use of BPA-free plastics in various formulations. Polycarbonate is commonly used in eye protection, as well as in other projectile-resistant viewing and lighting applications that would normally indicate the use of glass, but require much higher impact resistance. Polycarbonate lenses also protect the eye from UV light. Many kinds of lenses are manufactured from polycarbonate, including automotive headlamp lenses, lighting lenses, sunglass eyeglass lenses, swimming goggles and scuba masks, and safety glasses visors including visors in sporting helmets, masks and police riot gear. Windscreens in small motorized vehicles are commonly made of polycarbonate, such as for motorcycles, ATVs, golf carts, and small planes and helicopters. The light weight of polycarbonate as opposed to glass has led to development of electronic display screens that replace glass with polycarbonate, for use in mobile and portable devices. Such displays include newer e-ink and some LCD screens, though CRT, plasma screen and other LCD technologies generally still require glass for its higher melting temperature and its ability to be etched in finer detail. As more and more governments are restricting the use of glass in pubs and clubs due to the increased incidence of glassings, polycarbonate glasses are becoming popular for serving alcohol because of their strength, durability, and glass-like feel. Other miscellaneous items include durable, lightweight luggage, MP3/digital audio player cases, ocarinas, computer cases, riot shields, instrument panels, tea light candle containers and blender jars. Many toys and hobby items are made from polycarbonate parts, for example fins, gyro mounts, and flipper locks for use with radio-controlled helicopters. Standard polycarbonate resins are not suitable for long-term exposure to UV radiation. To overcome this, the primary resin can have UV stabilizers added. These grades are sold as UV-stabilized polycarbonate to injection molding and extrusion companies. Other applications including polycarbonate sheet may have the anti-UV layer added as a special coating or a co-extrusion for enhanced weathering resistance. Polycarbonate is also used as a printing substrate for nameplate and other forms of industrial-grade underprinted products. The polycarbonate provides a barrier to wear, the elements, and fading. Medical applications. Many polycarbonate grades are used in medical applications and comply with both ISO 10993-1 and USP Class 6 standards. Class 6 is the most stringent of the 6 USP ratings. These grades can be sterilized using steam at 120 degrees Celsius, gamma radiation, or by the ethylene oxide method. However, scientific research indicates possible problems with biocompatibility. Dow Chemical strictly limits all its plastics with regard to medical applications. Phones. Some major smartphone manufacturers use polycarbonate. Nokia has used polycarbonate in their phones starting with the N9's unibody case in 2011. This practice continues with various phones in the Lumia series. Samsung has started using polycarbonate with Galaxy S3's battery cover in 2012. This practice continues with various phones in the Galaxy series. Apple has started using polycarbonate with iPhone 5C's unibody case in 2013. Primary resin manufacturers and brands. Semi-finished products produced from polycarbonate. History. Polycarbonates were first discovered in 1898 by Alfred Einhorn, a German scientist working at the University of Munich. However, after 30 years of laboratory research, this class of materials was abandoned without commercialization. Research resumed in 1953, when Hermann Schnall at Bayer in Weddingen, Germany patented the first linear polycarbonate under the trade name Makrolon. Also in 1953, and 1 week after the invention at Bayer, Daniel Fox at GE in Schenectady, New York, independently synthesized a branched polycarbonate. Both companies filed for U.S. patents in 1955, and agreed that the company lacking priority would be granted a license to the technology. Once patent priority was resolved, in Bayer's favor, Bayer began commercial production under the trade name Makrolon in 1958 and GE began production under the name Lexan in 1960. Potential hazards in food contact applications. The use of polycarbonate containers for the purpose of food storage is controversial. The basis of this controversy is their hydrolysis occurring at high temperature, releases bisphenol A, 1/N, OC, OC6H4, 2CME2, N plus H2OA 2CME2 plus CO2. More than 100 studies have explored the bioactivity of bisphenol A derived from polycarbonates. Bisphenol A appeared to be released from polycarbonate animal cages into water at room temperature, and it may have been responsible for enlargement of the reproductive organs of female mice. However, the animal cages used in the research were fabricated from industrial-grade polycarbonate, rather than FDA food-grade polycarbonate. An analysis of the literature on bisphenol A leach at low-dose effects by Vom Zahl and Hughes published in August 2005 seems to have found a suggestive correlation between the source of funding and the conclusion drawn. Industry-funded studies tend to find no significant effects, whereas government-funded studies tend to find significant effects. Sodium hypochlorite bleach and other alkali cleaners catalyze the release of the bisphenol A from polycarbonate containers. A chemical compatibility chart shows that polycarbonate is incompatible with ammonia and acetone because it dissolves in their presence. Alcohol is one recommended organic solvent for cleaning grease and oils from polycarbonate. Bemediation, a species of fungus found in Belize, Getrichium candidum, has been found to consume the polycarbonate found in CDs. See also, CR39, Organic electronics, vapor polishing, references. External links